Did you ever think it would be a good idea to have a button that you can do things like home your printer or maybe start preheating without having to worry about going into your UI? Well, now you can. This is the Bigtreetech HBB. Hey everybody, how's it going? This is Patrick Stacking Layers. Today I'm going to be going over the HBB by Bigtreetech. This one in particular is the FE version, and there are actually two different versions, but I wanted to start off with the FE. This is the Founders Edition because this is a really cool little setup. If you can tell, it's a clear PCB. I thought that was really amazing, and they're pretty proud of it, and I see why. It looks good, right? Really, it doesn't add any benefits. It's just a cool factor. So let's get into the other one here, just so you can see what all comes with the packaging if you get it. So it gets, of course, you get an HBB. This one here is the normal version, and here it is in the standard black PCB style that they do. And if you look at both of them side by side, you can tell component layouts are identical. So you do not miss anything, any type of functions if you get this one compared to this one. This one's a slight higher price just because of the fact that it's that clear PCB. Something cool to have, but if you decide to go with this one, you're not going to lose out on anything. So just wanted to point that out. This is just about a cool factor. But anyways, so in the box, you get the board, you get a USB cable. You do not get the keycaps. This is something that I printed out. This is from the Bigtreetech GitHub. So they have available STLs ready to go. This is the standard blank one. So these are the ones that you would normally modify, but I just went and did some clear ones. And then some of these over here, as you can see, I have some dark ones. So just to see what the differences are, just to have buttons. So those aren't included, but I just threw them in the box. It did come with the ducts. If anybody's worried, the ducts were included, but my daughter confiscated those pretty much right when she saw them. So they're gone. I don't know where they are. But yeah, so that's hers now. But anyways, so I'm going to show you how to get these things set up. First, let's just go over the board. What do we got here? So we have pretty simple setup, actually. We got these 7 clicky keys, and here I think my microphone's picking that up. Pretty nice little clicky buttons on there. That they also come with LEDs. They got NeoPixel LEDs behind, so these little magnifying windows up on the top on each one is a NeoPixel. So it's got controllable lights and macros or whatever you want to do with these buttons to set, so you can control your printer. It comes with the Raspberry Pi Raspberry Pi RP2040 chip. So it's a really powerful chip. And with this chip, you can actually do a lot more than just 3D printer stuff. So if you stick to the end of the video, you'll find out some other cool stuff that I figured out that we can do with this board that's not 3D printed related. Pretty fun. So stick around for that. But before we do that, of course, we're going to do the Klipper stuff. We're going to get that set up, how to get everything plugged in. So it's running off a USB. It's not going to have any CAN bus or any special Wi-Fi or anything like that. It's a pretty easy setup. So this should be a quick and easy setup in general. It also has this nice little output for power. It's a low amperage 5 volt, and it really is designed to set this guy up. This is the Kenobi 2. So if you don't know what that is, basically this little thing is an ESP32 board with a touchscreen, and it allows you to basically have a small screen user interface for your printer. So it's designed originally to go inside the stealth burner head. So I think I have one right here. Let's see. Yeah, so it's designed to go inside here, right? Up inside that guy, which is pretty neat, but it is not limited to that. You can use it for all sorts of stuff. So my thinking, I got to figure out how to do it. I have this thing I've designed, so you can have that in there, and then this board in there. And then you can have a nice little duo combo. So you got all your printer readout stuff and your quick click buttons for running macros like homing and stuff. Something that's really nice. I've actually saw somebody already use this file and they put it on a small, I think it was a Voron 0. So it turned out really nice and it's very compact. And if you don't want to have a big screen, this gives you everything you need. You don't have to have the full Klipper screen UI. This gives you enough with your heating and starting prints and whatnot. And then these you can just do for your macros that you preset. So quad gantry leveling or whatever it may be. So some options there. It's pretty nice. I'm not going to be going over how to set this up. That's a whole nother video on its own. If you guys are interested, let me know. I haven't done a lot with this yet, but I am slowly getting into doing that. So let me know if you're interested in that. This file, if you are interested, will be in the description. It's completely free. So let's get this thing set up. But before we do that, of course, I want to give a huge thank you to my sponsor, PCBWay. I have this sitting here because they sent this to me, and I just thought it was really amazing. I thought originally this was acrylic, and I was like, how did they get all that cut out? But actually, this is resin printed. And you can see how clear, it's crystal clear. It's really nicely done. So I wanted to point that out because PCBWay does a lot more than just PCBs. As a matter of fact, for me, I've used them mainly for CNC and sheet metal banding because they do that really well too. And seeing this thing, might want to do some resin printing because I don't have a resin printer, and from what I've heard, they are very smelly and hard to deal with, a lot of mess and a lot of toxic stuff. So why not get it done? If you have just a couple little pieces you want to make, get it done. So here's a quick video about them, and we'll be right back. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWay has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video. And now let's get back to the video. Okay, welcome back. Let's get this thing set up. This is probably going to be one of the easiest videos that I've made because there's not a whole lot you really need to do with this. So it's going to be really simple. So let's get that going on. So first things first, we're going to program or set the firmware up. They do come pre-programmed, at least the two that I got already had firmware on it. So you actually don't have to do it, but I always recommend update to the newest one, newest Klipper, or the one that's matching your system as you're running it. So everything is on the same page. It's always good to do. So the way to do that, first things first is we need to get this into boot mode. Really easy. You have this little switch here. You hold that down while you plug in your USB into your MCU. So this is going to be, sorry, not your MCU, to your host computer. So that's going to be into your Raspberry Pi or Bigtreetech Pi or whatever you're using to run Klipper. Okay, so once you got that light on, you can let go of this button and it should be in boot mode. So let's hop on over to Putty. That's what I'm going to be using for here, but you can use any SSH program. So anything that you can get into your system running Klipper is all you need to do. So here I am, and we're going to be doing it on my Huracan printer. So first thing we need to do, well, before I get too deep, I'm assuming that you already know all about Klipper as a, you have your machine set up. This is an add-on, so I'm assuming if you're coming this far to doing these type of add-ons, you already have a running system. So I'm assuming you already have all your Klipper set up and it's up to date, okay? If you need any help to install that, I'll put a link up in the top here so you can follow along with Klipper for beginners. So what we need to do first is get into our Klipper folder, of course. First, I need to be able to type on the screen here. Let's see. So we need to CD into Klipper. And then we want to just run the make menu config. Should be there. Now what we need to do is get into the microcontroller architecture and then set it to RP2040. It's that simple. And actually, there's not much else you need to do unless you already have a different RP2040 that you've set up and there's different settings here. Then you don't need to change anything. But this is what you need: no bootloader, the W25Q080 flash chip. We're using USB serial, so that's good. Leave it there. No USB IDs are necessary to mess with, and no GPIOs. Everything else is pretty much all default. It's a really simple setup. So once you got all that set in there, you hit Q and for quit, and yes to save it. Then I always like to do a make clean before I flash, just in case there was anything there in the folder, and it can, any type of relics left behind or something like that. It's not necessary. Let's see, CLEAN, yeah. But if there is something left over somehow from a previous flash, it can cause problems. I've seen some people have problems. I tell them to run that, to make clean, and everything works after that. So I always do it anyways. Why not? Just, it doesn't hurt anything. And you should get something like this that says create symbolic link. You may or may not get that. If you don't, you can run it again and you may see it. It's not important if it doesn't show up, but that just lets you know that it was done. Anyways, moving on. So next, after we got it cleaned, we want to just do the make. And this is going to make the firmware. So it's going to be really quick, but I'm going to fast forward through all this so you don't have to sit and watch it with me. Okay, now that we got that done, we can go ahead and flash it. And we have already put our board into boot mode, of course, but just to double check, we can always do ls USB, pull that up. And as you can see right here, we have Raspberry Pi RP2 boot, and it has this number in front of it, and that's the number that we need to pay attention to. Yours may be different, but so far I haven't seen this number different while it's in boot mode. So if it is, just use whatever is in front of this, but just make sure it is the RP2 boot. What we need to do now is tell the make program. So we say make, I want you to flash, L-A-S-H. And then the next part here has to be all in capitals. So flash underscore device, telling it what the flash device is. And then equals, and then that's why this number is important. In Putty, you can just highlight it. It'll automatically copy, and then you right click and it'll put it down there. But that's what you want to put. So we have the make flash, and then the flash device is that. And it's that simple. We hit enter, and it should go through really quickly, just like that. Everything is flashed. It's that simple. So far so good, right? This is, like I said, is a really quick, painless setup. And so as you can see, you know, it did its thing. It found it, it erased, it flashed, and it rebooted the device. And as a matter of fact, if I go ls USB again, you'll see that now it doesn't say boot anymore. It just shows the open Moco Inc. Raspberry Pi. So it's good. It even has a different number now. So none of that really matters because we're not using it for anything. So one more thing we need to do before we get out of Putty here is we need to get our number for this, the serial ID. So easy way to do that is just the ls, and then we have dev and serial, and we have the by ID. And then I always put the slash and star because that basically appends anything, and it includes this part because when you copy it, you do need to have all of this with your serial ID in order for it to read. So when we hit enter, you will see now we got our listings here. Shows us what we have. If by chance you have more than one RP2040, it's possible because there are other boards like the SB2209 and stuff like that. So you may already have one set up. If you do, go ahead and unplug the HBB, run the command again, see what disappears and what comes back. You know, pretty simple, right? And that'll let you know. But the reason why there's two here is because this one on the bottom is my main board that controls the machine, and this is the new HBB board. All right, so what we need to do is copy this entire line all the way to that / because that's important to have the /. And then, like I said, with Putty, normally when you highlight, it automatically copies, but I do just in case, Control and Shift and C, that's to copy in Putty. Now we're good with that. We can move over to our printer to set up the configuration. So I am going over to my Huracan printer. So as you see here, got it all running and everything. And we go into the machine, and this is going to be to set up the profile first. So we're going to be setting up the configuration file. And to do that, all you have to do is come up to a create file, start something new. I'm going to label it hbb.cfg. That's the important part to it, that it's a configuration file. You can name it whatever you want, but I recommend keep it simple. So we'll go ahead and create that and then open it up. Of course, when you open it, it's going to be empty. So now all we have to do is come over to the Bigtreetech GitHub and of course to the HBB. I'll put a link down in the description to make it easy to get to. And we just get their sample HBB configuration. Just open that up. As you can see, they got things already nicely laid out. And all you need to do is come over to here where it says copy raw files, the two little squares on top of each other. Click that, go back to your new configuration file and paste it in. We're almost done. Like I said, this is really easy, right? So what you need to do is now come in here. Actually, sorry, we need to go back to Putty to recopy because I didn't copy that well. Well, let's see. Yeah, go back to Putty if you missed that copy, since I copied something else. Let's do this again. Copy all that. Go into there and then paste it. So what we need to do is paste it over here. There we are. So this is the important part because this is telling it obviously that this is the board it needs to talk to. If you don't change that, you're going to get errors. So that's your first step. So that's it for this part. I'm going to come back to explain what this is. There's one more thing that we need to do before this will actually work with your machine, and that is to tell the printer configuration about this. So just go ahead and hit the save icon. You don't need to restart yet. Save and X out. Because right now we have our configuration in this HBB config, right? But we need to tell the printer config about that. So that's what this is going to do now. So we go into our printer config. And of course, I always recommend doing all the includes because this makes it easy and organized. So go ahead and set that up. Come up here, add include with a space, and then the name of that file, hbb.cfg. And now printer configuration can know that this board exists. So go ahead and hit save and restart. And once it restarts, it should pop up in the system here. Granted, everything was set up properly. Yep, there it is. So now we have our HBB board right there in the middle. So now everything is set up, and that's really, you're good to go. If you know how to do any type of things like button configurations or the macros and whatnot, then you're good with that. But I'm going to go a little bit further just to explain what is going on inside this file here. So these are G-code macros, but they are specifically G-code button macros. So these are designed specifically for button pressing as it stands. So obviously it's button. So basically what's going to go on is each one of these functions is going to be set to one key. We have key 1, 2, 3. And if we go over to the Bigtreetech thing here, we can look at the pinout because they've labeled them in a very specific way. And I'm going to explain why. So if you notice, it says key 1 down here at the bottom right key is key 1, and then it goes to key 2 over here. And then up to the left in the middle is key 3, and then key 4 goes that direction. And then key 6 and 7 end up here. The reason why they label it that way is because of the LEDs. It's not really the keys. The keys you can organize however you please. If you want this to be key 1, that's fine. But with the LEDs, the pin for the LED is the first one is over here on the bottom right. And that's where the first LED gets controlled. And so the way Klipper reads things through, it has to read through the chain of LEDs. And they go through kind of a serpentine configuration in here. It's the way they're wired up. So this is number 1, and then it slips over to here, sends a signal to the next one up to here, and so on. I think you understand what I'm saying here. And because of that, they just label them key 1, 2, 3, 4, and so on. So if you have key 1, it'll be LED 1 also. All right. So here, let's go back over here and I'll show you that. So basically the way it works is we have the key 1, which is labeled there, right? It's on GPIO 25. And it's also for an LED, because you want to be able to control LEDs, right? You have them, why not? It's indexed 1. And so this is telling it which LED. So LED 1, LED 2, 3, 4, 5, and so on. And that's why they're labeled that way. Otherwise, it doesn't really matter. You can label this whatever you want. It doesn't have to say key 1. It's whatever you want it to be. The next area, so we have this says that you're going to make a G code with a button. This one tells the pin. This is obviously GPIO 25. So like I said, it's this down here, lower right. And it is saying that it's with the HBB board. This part right here is very important because this is telling it that it's talking to this MCU, which is the button board, the HBB. You can be named whatever you want, but whatever it is named up on the top here also has to match with all of these down here. If for some reason this is missing, so if you have it like this, it's going to assume that it's the main MCU, not this one here. So it'll be whatever that other board is that's controlling your printer. This can obviously cause problems if it's not a RBB because, an RP2040 or some sort of thing that has GPIO pins. It has something else like PB1 or whatever, because this is going to give you an error saying that GPIO 25 does not exist on MCU. And it's a little kind of not necessarily cryptic, but if you don't really understand those type of messages, then you're going to say, why, it's right there. I don't get it. It does have that pin. Mainly because you may have messed up in a copy paste or accidentally deleted it, and you don't have that HBB with the colon next to it. You must have it set up like that, because that's saying, I want to use this board, and this board has this pin. Make sense? Okay, good. Next up, I need to point out something very important is this press G code. It's a little confusing here because it says press G code and release G code. So you think with this setup, and when you press it, it should do something. Well, technically that's how it's designed to work. But by the way that this thing is wired, the button pressing is different. So the press is when it's actually released. I know it sounds wrong, but it is backwards. So press G code, anything you put underneath here. So if I were to add something to this zone here, like say if I were to do a G28 here instead, right? A G28X, that actually can cause a problem because what it's going to do as soon as your machine boots up and this board gets activated, it's going to send the command. So I basically recommend nothing, don't put anything under this line. The press G code, leave it alone. You could possibly put LEDs if you want it to be set to a certain LED all the time, you can do that. But what's going to happen is the next thing, the release G code, this is actually what happens when you press the button in. As soon as that button goes in, then it's going to start running this list of G codes, whatever you have in here. So for instance, on this one, it's going to run a home of the X, and then it's going to set the light to red. Pretty straightforward, right? But what would happen if you have something in the press G code, after this is done, because you're not still holding that button in, it's going to actually run the press G code button. I know it sounds weird and doesn't make sense, but it's because of the way that the buttons have been configured that they're in an upside down or an opposite. So the press is actually a release and the release is a press. Unfortunately, that's the way it is. I don't know why they did that, but that is how it is. I just wanted to point that out because that's probably going to be one of the most confusing things with these buttons if you're not, too familiar with how this type of stuff works. Okay, so just keep that in mind. Otherwise, the way it works, just keep everything under your release G code. Basically, what you do is you just put a list of G codes. After the release G code, you do need to indent. If you notice that these are all indented afterwards, if it's not indented, it can cause errors, or maybe even not run. It might cause an error, like it won't show you any error, but it just won't work. And sometimes it does just say that there's an error. So it's kind of back and forth. Depends on what code is there, I guess. But make sure it's indented. Anytime you run G code, stuff like this, it does need to be indented, okay? So this first one is saying, this one is saying to do a home. G28 is home, and it's home only the X. So when you press this, that's what it's going to do. Same thing with key 2. If you press that one, it's going to home the Y. Key 3 is Z, and so on. And then they got some other stuff here set up. This is all just stock stuff to get you sorted out with, more or less just kind of organizing things. Then you got G28, that's home everything. M84, honestly, I can't remember what that is off the top of my head, but that's there. But the next one is going to be the M104. That's your nozzle or your hot end heating. So it's going to set the heat to 200 degrees. And then you have the last one here is on a M140, and that's your bed heater. And that's going to heat it to 60. So those are like for preheating type of things. And each one has a different type of LED color that it's going to set up. At the very bottom here, you have your NeoPixel setup. So this is just to basically define the NeoPixels. There's 7 of them, and it's being controlled by GPIO 20. You can set, if you want your board to be lit every time you start your printer, you can have it set up to here, and that's what these 3 zeros are right now. It means off, but you can set them up, and it's any blend of these 3 colors, the RGB. And to do that, all you would do is add something like, say, for instance, 0.5. That's going to be 50% of the red light. So the way these work is a 1 is 100%, a 0 is 0%, and then any point after that is a percentage of that. So you want 30%, you do 0.3. That's 30%. 1 is the maximum number. 2 is not going to get anything except for maybe an error. So 1 is the max. That does mean 100%. We'll leave these at 0 right now so they don't turn on when we first start up. But that's all set up, ready to go for you. You're good there. So other ways, other things you can do, for instance, if you don't want it to be red or you want to change different colors or whatever, you can do that. You can even set up with these macros, you can set up as many different things as you want. So say, for instance, you want, when you click this button, you want it to first home the Y, right? So you can actually set that up to do that. Get that in, put this here, and this will do it to where it homes the Y first and then the X, and then it turns on the LED. Or you can even do it to where you take this LED, let's copy that and put one more line in here. You can put it to where it homes the Y first and then turns the LED green, letting you know that the Y has been homed. Turn this to 0. And then we can change, we want it to blue, for instance, not red. So after the Y homes, it should turn it green. Then when the X homes, it'll turn it blue. And that'll let you know the sequence has been completed. And then because there's nothing on the press G code, it'll stay there until whatever else gets ran. All right, so let's go ahead and save and restart this so we can see that in action. Get over to our dashboard here. So you can see nothing is homed here. This is the webcam of my printer live. It's there behind me. And so what I will do is press that one that was the X and Y and see what happens. So I'm going to press this button here. As you can see, my machine started doing its homing. It homed the Y, it turned green. Now I did the X and it turned blue. Pretty simple, right? So that's basically what this board is all about. I know the, let's see, was X, Y, Z, and the middle one here is home all. So this one should do another home. And you can see, here it is, home all. Everything's going good. And then once it's done with that sequence, it should turn this red, I think it was, or maybe green. I don't remember what that was. We'll see in a minute. There it is, it turned green. Probably a little too bright for the camera there. So that's the gist of this board. So I mean, that's a pretty cool thing in itself, right? Because you can set up whatever macros you want. For example, if you have one where, you know, for something that's quad gantry leveling, for example, or, you know, you want to do your Z gantry tilt. You have to home your printer. A lot of times you want to have your heat already up and then you want to run the thing, you know, so instead of going through and going into your screen and clicking all of those things, you can set one button to first preheat and then wait. Once it's preheated, then run your homing sequence. Once it's done homing, then it'll run the quad gantry level, for instance. So you can do all of it in sequence, which is one press of the button. So that's where these things start becoming powerful. It's not just a quick little home or turn on your heater. Obviously, that's pretty simple in itself, and it's not many button presses on the screen to do that. But for a quad gantry level, like I just described, you can go through the whole process and be done with everything. So if you have something that you do on a regular basis, it's a really nice thing to set up. So that's the HBB board, and that's what it does with Klipper. But like I said, you waited to the end. There is actually quite a bit more that you can do with this board. It gets really exciting, at least for me. I thought this was really exciting. So we're going to put this one aside and we're going to pull this one out because this one is programmed a little bit differently. So give me a moment. Okay, so what am I talking about? Why is this even better or more exciting? Well, if you're not aware, the RP2040 chip is more than just a little MCU that can be used for Klipper type stuff. This is actually a full-on microcontroller. And because of that, it actually can run CircuitPython. CircuitPython is a Python, or the Python programming language, shrunken down or basically made to work on little microcontrollers like this. So, you know, like Arduino has its own little ecosystem and you can program it with like a C++ version of their own ID or whatever, so their own coding language. So can you do with this, but you're using Python. So if you know how to use Python, you already know this is going to open up a huge world of customization and all sorts of fun stuff that you can do. If you don't know what CircuitPython is or Python in general, it is a programming language. And so I will swap over to this guy here. So this is the CircuitPython website. It's really easy to set up. You just go to the website and you download the Pico image. So this is right here. This is designed for the Pico, but if you notice, you can see that here's the Pico lane here. And if you look at the back here, I mean, it's relatively the same thing, right? You got your USB, you got a button. There's the button right there, the boot button. USB, of course. You got some circuitry for the USB to communicate and to relay power because it steps it down from the 5 volt to the 3.3. You got the Raspberry Pi chip, the exact same chip. Little crystal for it to do its thing. And then you got some GPIO pins. So that's the biggest difference is this, the Raspberry Pi Pico has all the pins broken out, whereas this one doesn't, except for whatever is already attached here. So I think, you know, Bigtreetech, if you're watching this, a really cool thing to do. You got lots of room on this board. Make a version 2 with some pinouts. That would be pretty awesome, just to have little soldered pinouts like it is on the Pico board. Why not? You know, give some more options because this thing is now going to get really cool. So what you do is you download this file up here, and then you do the same thing. Once you got that downloaded, you do the same thing where you put this into boot mode. And so you basically just hold down the boot button and then you plug it in, but you plug it into your computer, not into your MCU, because now we're doing things on the computer. So what that's going to do is open up, let's see if I can get this to show. So it opens up something like this, right? And so all you would do is get that file that you just downloaded and drop it into this here. And as soon as you let go, it'll disappear. I'm not going to show you here because I already have some other stuff pre-set up and I don't want to go through the whole setup. I'm not going to go tell you how to go through the full programming on this because it is Python and I'm still learning it. I'm not a pro at scripting whatsoever. So I'm not going to go into details, but I'm just showing you the really quick and dirty way to get this set up. So basically you drop that file into there that you downloaded from this site here, right? So you got this thing here you download, put that into the folder and it'll disappear and you're good to go. What that's going to do is it's going to automatically install Python and then, or CircuitPython, it'll automatically put it into your system. And then you will have something along the lines of this. So now you have CircuitPython on the board, ready to go. It'll even have the little code py. So this, whatever you put in this code py file is what will actually run on default. So you don't have to have it plugged into your computer even. You just give it power and it'll start doing its thing. So the main two files is this file here, and then this file. And in this folder, you have your library. So these are things you would add on. So because I'm going to be doing some other stuff, I have NeoPixels to control the pixels. I got HID, that's the human interface devices. So we can do some other fun stuff like key mapping. So let me show you what I'm talking about. Why is this all important? Why is this fun? If you guys know what I'm talking about, you probably already see where I'm getting with this. But let's see, let's get this closed out. And then I'm going to go into another program I have open. And this program is, okay, so this is Tony or however you would say that. This is what this is a Python IDE. So this is something that you would use to program Python in. This is a really simplified version of all different things. So you can use VS Code if you want and whatnot, but this is a really nice setup because it has everything that you need for Python built in. So when you come into here, basically you got to do a couple things to get it set up if it's not already done. So you want to come into your view. You want to be able to view your files. And I like to also view shell. That just gives us an ability to communicate with the Python running on the system if you want to, or to see any type of like serial outputs if you program that type of stuff into it. So when you're in the files, it may first look like this. And so you want to make sure that you select the one that's a CircuitPython to get into that, and you'll be good to go from there. And then one last thing you want to do is make sure that you're running the interpreter in the CircuitPython. So it'll be in here. I think default is local Python or something like that. So just make sure you're on CircuitPython to get that going. All right, everything else can be left the same, left default. Hit OK, and it should, like you see down here, it actually has connected, and now we are in Python. We can run script and just do Python stuff here if you wanted to. That'll work because it's running. But we're not messing around with that today. What we're doing is a quick little just demo on what you can do with this. So what have I done here? This here, as you see, it's HBB, copy the pattern game. And that's right, I've made a game. I do want to point out, I am not a programmer. I am completely self-taught. So this is all stuff that I have done with the help of ChatGPT. So that's why I want to say that this board is pretty amazing, that you don't even have to be a programmer to do things like this. You can just hop over to ChatGPT, tell it what you wanted to do, and then go through and problem solve. You know, it didn't give me this script immediately. I had to tailor it. I had to keep telling it, no, I don't want it to do that. I wanted to do this. You know, I set up what the buttons were. There was a couple weird things with that we had to figure out. And yeah, so it went through and we were able to get it all going. So it was really, really nice. And surprisingly works beautifully. So basically what I have here is it just maps out the buttons and it gives it some LEDs, and then it goes through a program. It's an actual game program to do a follow the pattern. So I'm not going to go through the code because honestly, I can't give you every explanation of what's going on here because I'm still learning that. And that's not what this video is about. I just want to show what you can do. So to get this going, all you have to do is make sure that you're in that specific one, and then you can just run it. This is not going to install. If you want to install that, what you would need to do is open up this code py and then actually copy this code into that one. So whatever is in this code.py will run as long as the board has power. So let's get this ran. And it is running. And at the moment, nothing really happens. But if it's running properly, hopefully it is. When I double click this, as you can see, I put the code, the keypads on there. So I double click this. There it goes. It starts into this little countdown. And it just gave me a blue light. So what I have to do is press that blue light. I got it good. It went green. Now there's 2 of them. Went green. So as you can see, I have literally just designed and installed a game onto the HBB by Bigtreetech. If I get one wrong, then it goes into this little mode, says, and you're wrong. And that's it, game over. If I want to start again, I have it set, double click the center button here. A little bit faster maybe? Slower, there we go. It's not perfect, of course, but it's the first time I've ever done this, so I don't expect it to be. So pretty neat, right? And that's a game. Running on something that's designed just to run macros on your 3D printer. But now, as you can see, you can program it to do lots of other things. This really opens up a lot. As you can see, it's more than just a quick little Klipper macro board. This does all sorts of stuff once you get CircuitPython on it. So really start using imagination and you know, figure out what you can do with this. It's unlimited, you know, of course, obviously limited to the hardware, but it does a lot. So yeah, that's why I was saying, you know, Bigtreetech, again, if you're seeing this, put some more GPIO pin outputs here. Go ahead and just add those out. I mean, they're there, they're not being used. Send them out, let us do some more stuff with this, make a version 2 board. That thing's gonna be awesome. So anyways, what do you guys think? Is this something interesting to you? Is that extra feature something that you would want to use? I think it's amazing. I am really happy that it does this. So it's going to be fun. I want to give one more big thank you to PCBWay. You guys have been a massive help for my channel. Thank you very much, guys. Check them out. They're really cool people. They got all sorts of good stuff. And like I said, it's not just PCBs. Huge, massive, massive thank you to all of my new subscribers. Welcome aboard. Thank you for coming in. Shows me that what I'm doing is meaningful in some way, and that's great because that's my goal is to help out people. So it's good to see you guys coming in. Let me know down in the comments what you guys think. If you have any suggestions, any pointers, tips, all that fun stuff. If you guys make anything out of this, if you guys decide to get one and do a Python, CircuitPython, show me what you guys come up with. I'm really curious of what else people are going to be doing with this type of thing, with this information. If you guys also, if you didn't do the Python, but you did make some really cool macros for your 3D printer, share them. You know, I'm sure everybody out in the community would love to see different types of ways of, you know, setting up their macros in their printer. I'm going to cut this video off now before I continue to ramble on and just say thank you once again. And until next time, get out there and make something. Thank you for watching.